Hey there. Today's video is about factoring quadratic expressions where the leading coefficient of the expression is not equal to 1. Okay, that was kind of a lot, I know. So I'll tell you exactly what I mean. So in a previous video, we went over factoring where the leading coefficient, and I'll explain that really quickly again. The leading coefficient was 1, and that's this here. That's this coefficient, the number in front of the first or the highest degree term is 1. So we did this in a previous video. Today's video is all about what to do when that's not 1, and what we use is a method called factoring by grouping. That's what we've got to do when that leading coefficient is something other than 1. So let's start off by doing a binomial expansion example so that you can kind of see how we might end up with a quadratic that has that leading coefficient greater than 1. So if you were to take, for example, 2x plus 1 times x plus 3. And we were to expand these or FOIL them, then I'm gonna, instead of FOILing it, which I could FOIL this, it's kind of like a shortcut to making sure that we expand this correctly. Instead of FOILing it, I'm actually gonna go back to the beginning of when you originally learned binomial expansion, and I'm going to distribute this group through the other group, okay? Distribute that group through the other group. Because the reason why is because that concept is going to be really important later when I'm showing you factoring by grouping. So recall that if we were to multiply something like, let's say the constant, let's say a was some constant, and we're going to multiply it through the group x plus 3. I think that you could probably do that. You'd need to distribute. So the ax plus, I guess, 3a. The a needs to get multiplied by both of the things in that group, right? So just because this 2x plus 1 is like a little bit more complicated kind of structure, it's still being multiplied by this group on the right, and it still needs to get distributed to each of the terms in that group on the right, okay? So then it needs to be, the x needs to get multiplied by the 2x plus 1, right? And also the 3 needs to get multiplied by the 2x plus 1, okay? And then, of course, we need to do some more distribution through the parentheses. This x has got to get distributed for those two, and this 3's got to get distributed through those two. And so we get left with 2x squared plus x plus 6x plus 3. We can combine those like terms in the middle for 2x squared plus 7x plus 3. Okay, so that was expansion, binomial expansion, and it left us with this leading coefficient that is not 1, because we started with a coefficient on x in our original binomials. So that's how we ended up with that. Now, in factoring by grouping, we're essentially going to just reverse engineer that process. And it's just a technique by which you can go backwards in that process and get back to the binomials. And it's a little bit, maybe a little bit challenging at first. So I've got 2 examples for you, and there's plenty more examples online. I can even make more examples for you later if you're interested. But you will need practice with this one. This is not usually the kind of video or the kind of technique that you do one time and you feel great about it. You're probably going to want to do some practice problems with this until you feel really good. Okay, so before we get into the first example, I want to point something out to you. Suppose that you had this expression. I want to point out that hopefully by now in your algebra learning career, you would be able to factor out from both of these terms a common factor, okay? In this case, both of the terms had a b in them, and we could factor out that b from each of the two terms and leave b times the group 2x plus 1. I hope that makes lots of sense. Now here's the thing that's trickiest. This is why I'm leading with it. This thing that's trickiest about factoring by grouping. We're essentially going to do that very same thing I just did with b, except we're going to do it with a more complicated thing. Okay, so imagine if we had a very similar situation. We had 2x times x plus 1 plus x plus 1, okay? I want you to notice that this is really, really, really similar because this thing, x plus 1, is essentially filling in the same role that this b was filling in the previous example. Even though it's a lot bigger, a lot more complex looking, it's just something that is multiplied by 2x and something that is multiplied by 1, and we can factor it out in the same way that we factored out that b. And realizing that is essential for being able to do factoring by groupings. That's what I'm showing to you. So we can see that x plus 1 factors out of each of those two terms, and it leaves a 2x and a 1. And we can see that if we were to reverse the process and distribute the x plus 1 back through, we would end up back with what we originally had, okay? So that's to say, you can factor things out that are more complicated than just a number or a variable. You can factor out whole groups like this, and that'll be an essential step. Okay, with that done, on to our first example, okay? Example 1. So suppose we have, let's see, 3x squared plus 14x plus 8. We see that the leading coefficient is not 1, and there's nothing that we can factor out of all of these things to make this any easier. Like you can't factor a 3 out of every term or anything like that. And so right from there you should go, okay, it looks like I'm gonna have to do factoring by grouping. So here's the process. You take the leading coefficient and the constant at the end and you multiply them together. So that's gonna be 24. And then you take that coefficient from the middle, 14, we're looking for, kind of similar to factoring where the leading coefficient is equal to 1, but we didn't have to multiply by that leading coefficient, right? We're looking for numbers that multiply to 24, but that sum to 14. So let's go on a search for those numbers. Let's see, 124 multiplies to 24, 2 and 12. Oh, and I think I'll stop right there because I can add 2 and 12 to make 14. So I've found my numbers. Now, recap. We took the leading coefficient, the constant. We multiplied them together to equal that 24, right? Then we said, okay, what two numbers multiply to 24 and sum to 14? And we found those two numbers. That's the first thing you've got to do correctly when factoring by grouping. The next thing is we just break up that middle term into the two pieces that we just identified. So let me just show you what that looks like. 3x squared plus 2x plus 12x plus 8, okay? Notice that we broke up 14x up into a 2x and a 12x. That should be fine. Those are the same thing. And we pick that 2 and that 12 really carefully, and in a second you'll see what it does, why we pick them so carefully. So notice that these two terms and these two terms, both of those two groups have each one has a common factor. This first group, the factor x is in both of these terms, okay? I can factor that out and it would leave a 3x plus 2, okay? So I just want to see that this 3x squared plus 2x, I could factor x out of each of those and it would be x times 3x plus 2. Then on this group, here also there's something I could factor out. I could factor out a 4 from each of these terms. And that would leave me 3x plus 2. Okay, all right, so notice here, this group, each of the two terms in that group had a factor of 4 in them. I could factor it out, and that leaves me with, lo and behold, and this is very important, the exact same group structure, 3x plus 2 on the left and a 3x plus 2 on the right. The reason that happened is because we selected the way to split up that middle term cleverly. We did a good job. Now, here's the part that I told you would come. We need to now factor out this group out of these two terms, okay? So it's just a thing that's multiplied by x and a thing that's multiplied by 4, and it's the same thing, so we can factor it out. So I'm gonna factor it out and take it out front, I guess. And it leaves an x plus 4, okay? So this group, notice, what I just did was totally legal because I can go back the other way. If I were to distribute it through the group, I would end up back with where I started. I would end up with x multiplied by 3x plus 2 and 4 multiplied by 3x plus 2, okay? We did it. Look, it's two binomials, which when multiplied together equal the thing that we started with, okay? So that was the process. I know it's definitely a process, and it will take you some time to feel comfortable with it if this is, you know, some of your first experience with it, okay, for sure. But it is just a process. As soon as you get it down, you're gonna get really, really good at it, and you're gonna get fast at it, even if it's a little bit abstract now, okay, I promise. That said, let's take a look at a slightly more challenging example. It's a little more challenging because the numbers are a little bit bigger and because we got some negatives in there. So let me show you my example 2 for you. Example number 2. 2x squared plus 9x minus 35. That's 5. Okay, so first step, take that leading coefficient and the constant and multiply them together. That's 2 times negative 35 is negative 70. And so what we're looking for is two numbers that multiply to negative 70 and that add to 9, because that was the coefficient on that middle term there. So let me go ahead and just do a little search for those. Let's see, we could do negative 1 and positive 70, or positive 1 and negative 70, or negative 2 and positive 35, or positive 2 and negative 35. It's not divisible by 3. Not divisible by 4. It is divisible by 5. Let's see, 5 times 14. Negative 5 and positive 14, or positive 5 and negative 14 will do. And then it's divisible by 7, 7 and 10. And that's it. Again, they could be positive and negative, or negative and positive. And if we go through these, remember, we're looking for a pairing of these that sum to 9. So let's take a look. I think I found it in here. Looks like positive 14 and negative 5, if we sum those together, it would be 9. So we've found the ones we're looking for. Now, after we find those numbers, we break up that middle term. So it's 2x squared minus 5x plus 14x minus 35. Then, for each of the first two terms and the last two terms, we factor out any common factors in each of those first two or last two, right? So in the first two, we got 2x squared and negative 5x, and those share the factor x. So I'll factor that out. Leaves me with 2x minus 5. And then the last two, we got 14x minus 35. Both 14x and negative 35 share the factor 7. So I'll factor that out. And that'll leave, again, 2x minus 5. Now remember, if you don't get the same thing here, something went wrong. It was likely that maybe you didn't select the right numbers for these two numbers, okay? If you selected these according to the rules that we're talking about, then you'll always find that you'll get the same binomial here, okay? So notice then that we got this same thing, 2x minus 5 and 2x minus 5, and that same group is being multiplied by both x and 7, and since it's the same, we can factor it out of each of these two terms. And that would leave us with an x plus 7 multiplied by 2x minus 5. The 2x minus 5 got factored out of both the x times 2x minus 5 and the 7 times 2x minus 5 terms, and left us with two binomials factored, okay? So I know this is a process that is a little bit abstract to learn. More than happy to do more example problems with you, but at the end of the day, it'll just be a matter of you going through these things kind of slowly over and over again until you get comfortable. That's just how it has to go. Anyway, I hope that you found this video helpful in factoring by grouping, and I will catch you soon. See ya.